Now we want to compute this integral. The function is f of xyz is equal to x, and the region is the solid that is bounded by the surfaces z equals x, z equals 2 times the square root of x, z equals 8 minus y, and y is equal to 0. If you remember what I said in a previous video, we determine the innermost integral by seeing which variables' limits are defined in terms of the other variables. Now, the way that I've given you the problem, I've defined the z limits in terms of x and y. In other words, the surfaces are z equals x, z equals 2 times the square root of x, z is equal to 8 minus y, and y is equal to 0. So you might be tempted to think that the inner integral should be the z integral. And you could do the problem that way, but the problem is that you would have to split that integral up into two integrals because the lower limit on the z integral would change. So really, no matter how you're given the problem, you need to visualize what the surface is or what the region is that you're going to be integrating over, and from that decide what the boundary should be. So let's try to visualize what this region is going to look like. So I'm going to begin by sketching the graphs of the curves z equals x and z equals 2 times the square root of x in the xz plane. Now notice that in this drawing, the positive y-axis is going into the screen and the negative y-axis is coming out of the screen. So if we forget about the y stuff, if you forget the z equals 8 minus y surface and the y equals z surface, then what we have here is going to be what we might call a parabolic, or sorry, not a parabolic, some sort of cylinder, but not a circular cylinder. And the cross sections, instead of circles, the cross sections are going to be these shapes, or these curves right here. So it's kind of going to look like an infinitely long airplane wing. Now, if we add in the y equals 0 surface, well, this just means we don't care about the part of this cylinder when y is less than 0. So it's not going to come out of the screen, it's going to go into the screen infinitely in the positive y direction. And then if we add the z equals 8 minus y plane, that's just going to chop off the cylinder farther down in the positive y direction. Again, I would encourage you to graph these surfaces in GeoGebra to see what this looks like. So actually, it makes more sense to have the y integral be on the inside. And the y integral is going to go from 0 to 8 minus z. So now I've solved the z equals 8 minus y for y in terms of z. And we're integrating the function x, so dy will be there. Okay, and now for the x and z integral, which one should go first? Well, it doesn't really matter. Either one is about equally difficult or equally easy, depending on what your perspective is. I'm going to have the y integral be in the middle. So that means for every value of x, the z integral will be the middle integral. This means for every value of x, z is going to go from x to the square root of, 2 times the square root of x. Oops, and let me make that black. And then x will go from 0 to 4. Where these two curves intersect is 4, 4. Okay, so this is the integral x equals 0 to 4. The integral z equals 0 to 2 times the square root of x. As far as y is concerned, x is a constant, so this is x times 8 minus z. And this, I will let you do this at home. This is 2, 4, 3, 2 over 15. So the novelty of this problem is that I gave you the region, I gave you the boundaries of this region, the surfaces that bound this region, in a way that made it seem like the z integral should be on the inside. But actually, once you visualize what this region looks like, you see that the y integral needs to be on the inside, and then the x and z integral need to be on the outside. Whether you do x first or z first, it doesn't matter.